A long time ago, in about, the 1770s, in a land far away, aka Germany, there was a little boy named Carl Friedrich Gauss, who at the time was just a little boy, but would later become known as the Prince of Mathematics. Now, when Gauss was a little boy, he was in, ye old one room schoolhouse, learning math. And one day his teacher just kind of wanted the kids to leave him alone for a minute. So he set them with a problem. He said, okay, I want you to figure out what do we get if we add up 1 plus 2 plus 3 plus 4 all the way up to 100? What do you get if you add all those numbers together? And he set the kids off to figure this problem out, kind of figuring like, all right, this will give me a little bit of a break time. They didn't have calculators, right? So they have to figure it out by hand. Well, Gauss sat there for a minute and he thought for a minute, and then he said, oh, well, the answer is 5,050. And the teacher was a little bit baffled about how he could figure this out so quickly because it was supposed to be a time wasting activity, right? Well, Gauss, again, later known as the Prince of Mathematics, the dude was pretty smart. So what he did was he thought about this and he said, okay, the numbers that I'm adding together 1, 2, 3, 4, 5, and so on. Right? And eventually, instead of kind of thinking about this list going down forever, he kind of thought about it looping back up. Right? The last number would be 100, and then this number would be 99, this number would be 98, 97, 96, right? And we kind of think about it like a giant U, where these numbers come down and they loop back up. And he kind of looked at it and he said, well, if I add the first number and the last number together, that is going to add to 101. And if I add the second number and the second to last number, that's going to add to 101. And if I add the next number and the number after that, that's also going to add to 101. And while these numbers keep getting bigger by 1, these are getting smaller by 1. So they're always going to add to 101. So if we think about this for a minute, right, all I need to know is how many different pairs am I going to have? Where is going to be that spot where they meet up down here, right? What'll be that final pair that'll show up? Well, it's 100 numbers, so 50 seems like a good place to look. And if I had 50 in this first column and 51 in that column, that would give me my sum of 101. So how many pairs do I have? I have 50. So he just said, well, all I have to do is take 50 and multiply it by 101, and there's the sum of all those numbers. Pretty impressive for a little boy. Like, we're talking like less than 10 years old here, right? Figured this all out on his own. So that right there, what Gauss learned here when he did the sum of 100 numbers, is going to be kind of the idea of what we're focusing on today. So today we're looking at arithmetic series. So yesterday was arithmetic sequences. Now we're looking at series, okay? Well, what's the difference between the two of them? The difference is that an arithmetic sequence is just a list of numbers. An arithmetic series is the sum of that particular list of numbers. Okay, now you're going to notice that it says indicated in bold here. Okay, that's because generally arithmetic sequences go on forever, right? Like this guy here does. So you have to indicate how much of the sequence do you want to add together. There is such a thing as a sum of an infinite sequence. That's a thing that you can do, but not something we're going to worry about in this class. So we're just looking at arithmetic series where we're going to say, okay, they're going to want the sum of the first 8 terms. So that's what they're indicating about the sum. You only want the first 8. Okay? All right, so when we look at this guy right here, if I want to try to figure out the sum of the sequence, right, you can pretty easily see my common difference is 3. So if I want the first 8 terms, I'm just going to go ahead and list them out. So after 8, 9, 10, 11, and then we have 14, 17, 20, 23, that'd be what? 3, 4, 5, 6, 7, 8. So that should be all 8 of my terms. Okay, so those are the numbers that I want to add together. So we are going to think about this like how Gauss would. Okay, so if I think about this and I say, all right, well, how can I use this pair thing to make this work out for me? Well, the first numbers that I would add together are the biggest number and the smallest number. Those add to 25. Right? And then if I look at the next biggest number and the next smallest number, well, those two are going to add to 25. And then if I look at the next pair after that, 8 and 17, those are going to add to 25. And then this final pair here, Well, those also add to 25. So what do I have going on here? I've got 1, 2, 3, 4. So I have 4 pairs of 25, which is 100, right? Now, this is a pretty small list. There's only 8 numbers. Adding those together, you probably could have thrown that in a calculator and it wouldn't have taken you too long. All right, but we're just kind of looking at some small lists right now. It's going to get a little bit more complicated as we go. Okay, so we got 4 pairs of 100, 4 pairs of 25, so our sum is 100. Great. All right, well, let's look at this guy right here and see if we can apply that same thing. So again, I'm kind of looking at what I have for pairs here. When I add the first number and the last number, 29 and 5, that's 34. Okay, if I add the 9 and the 25, that's 34. 13 and 21, that's 34. But here's where this list is different from that one. This one we were looking at 8 numbers, so that's an even number of numbers. This guy I've got 1, 2, 3, 4, 5, 6, 7 numbers, right? So this is an odd number of numbers here, which sort of screws us up, right? We've got this 17 chilling out in the middle here, and he's not really a pair. But do you notice that 17 is exactly half of 34, right? Which kind of makes sense. It's in the middle, so if you doubled it, you'd end up with the extra half of your pair. So when we look at what's happening here, I've got 7 numbers. If we think about this, this is like having 1, 2, 3 and a half pairs of 34, right? So this is like 3 and a half pairs of 34. Okay, well, 3 and a half pairs of 34, if I multiply 3 and a half times 34, that's going to tell me that my sum is 119. All right, great. So now let's talk about generalizing this into a general formula. What are we doing here when we do these problems? Okay, well, to find the sum of the first n terms, okay, so that's your notation. So this guy right here means the sum of the first n terms. So in this case, we found s sub 8 because we found the sum of the first 8 terms. This guy we found s sub 7 because we found the sum of the first 7 terms. All right, and what are we doing to calculate this? Well, the first thing that we're doing is we're saying add together the first term, a sub 1, and the last term, a sub n, right? In this case, it was a sub 8. In this case, it was a sub 7 because we had 8 terms and 7 terms respectively, right? And then we're multiplying that sum by how many pairs we have. Well, how many pairs do we have? When I had 8 terms, there were 4 pairs. When I had 7 terms, there were 3.5 pairs. So you're just dividing the number of terms in half, right? Which makes sense, they're pairs. So I'm taking how many terms there are and dividing it by 2. Okay, so that is my formula for figuring out the sum of an arithmetic series. And while this is a very useful formula, right, sometimes memorizing this stuff can be a pain in the butt. If you can work through this logically like how Gauss did, then you never need to worry about really memorizing this formula. Okay, so let's look at some examples. This guy right here, we want to find the sum of all these terms. Now, in order to be able to do that, I need to know the first and the last term, but I also need to know how many terms I'm adding together, right? I need to know what n is so I know how many pairs there will be. And this doesn't tell me. So the first thing that I'm going to have to do to successfully complete this problem, step 1, is I need to figure out what n is. Okay, so I have to start by calculating n. If you didn't know before, I have a lot of clocks in my house, and it's noon, so they're donging a lot. Okay, so we're gonna start by figuring out n. How are we gonna do that? Well, we're gonna go back and use the rule for an arithmetic sequence that we did before. I know the first term and I know the last term, and I can pretty easily figure out that my common difference is 4. So I'm gonna use that to figure out how many terms there have been. Okay, so to figure out whatever a sub n is, I always start with a sub 1, the first term, and I add the common difference, n minus 1 times, right? I know a sub n, that's 165. I know a sub 1, that's 5. I know the common difference. Those are all going up by 4, right? N is the only thing I don't know. So here's my little baby equation to solve. This is going to be 160 equals 4 times n minus 1. You could distribute and solve from there. I'm just going to divide both sides by 4 though. So I'll get 40 equals n minus 1. So then n is 41. Perfect. All right, so now I know what n is. Now I can go back and use this whole idea that we've been talking about. So now for step 2, I'm going to actually find the sum. Okay, so I know that my sum, I'm finding the sum of the first 41 terms, right? And I'm adding together the first term and the last term, so the 5 and the 165. That's what my sum is. I'm multiplying it by how many pairs there are. I have 41 terms, so it's going to be 41 divided by 2 for the number of pairs. Right? Grab your handy dandy calculator, and that's going to tell you that the sum of the first 41 terms is 3,485. Excellent. All right, now let's look at this next one here. Now we're going to find the sum of the first 50 terms in this series. So now I know how many terms I have, but I don't know what the last term is. So before we can do this, my first step is going to be I have to find a sub 50, the last term. All right, and again, I'm going to go back to what I know about arithmetic sequences, because all a arithmetic series is the sum of a sequence. So to find the 50th term, I would start with the first term and add the common difference, 50 minus 1 times. Okay, well, I know a sub 1, it's 5. I know my common difference. I'm always adding by 4 here. Great. And then 50 minus 1 is 49. So that means a sub 50, throw that in my handy dandy calculator. That's going to work out to 201. Lovely. All right, and now that we've gotten that part, now I can go back for step 2 and actually find the sum. Okay, so finding my sum. So to find the sum of the first 50 terms, right, I'm adding the first number and the last number. That's what we just found. And how many pairs? I have 50 terms, so I'm going to have 25 pairs, right? 50 divided by 2. Plug that into your handy dandy calculator, 5150. All right, so now we found a few of these different sums. So one more thing that we just got to talk about is summation notation down here. This may look vaguely familiar to you. Maybe you've even done something with it before, but maybe not. So all this is it is a different way to write exactly what we've just been doing, okay? Sorry, I got to shift this paper. Okay. And then my computer screen turned off, so hopefully that kept recording. I don't know, you might have gotten something weird there. All right, so anyway, what this is, it's this weird notation. This giant squiggly shape here, okay, that's a Greek letter sigma, it's a capital sigma, and that just means sum in mathematics, okay? So this symbol right here, that's not an S. Sigma, right? And it just means sum, okay? So what this is telling you to do, right, is it gives you 3 pieces of information. It's telling you to take the sum of all the terms in a sequence. So this guy right here, this is going to be whatever your rule is for the sequence. Remember how yesterday, at the very end of our notes, we said that we could write a formula or rule that described the sequence, and we figured it out that it was going to be this, right? Well, this 3n minus 1, that's the part that would show up here. It wouldn't say an, it would say 3n minus 1 here. That would give you your rule, okay? And then this guy tells you what the first term in your sequence is going to be. So this is the first term that you're adding together. And this guy tells you where to stop adding. So this tells you what your last term will be. Okay, so this is usually going to say n equals 1 because you're going to start with the first term. And then this will tell you what your last one is. So for example, on this guy here, right, we found the first 50 terms. You would see that it would say n equals 1 here, and up at the top there would be a 50 because we found the sum from the first term to the 50th term. Okay, and then this part would be that something like 3n minus 1, whatever the rule is for this particular series, that would be what goes here. Okay. So let's talk about actually making one of these, okay? So we're going to put one of these together, and then we'll go from there. Okay, so this guy we're going to put in summation notation. So in order to do that, all right, the first thing that we have to do is find a rule for this sequence, Okay, so we're like writing a formula just like we did yesterday. So step 1 is we are going to find the rule. All right, and remember, this is where you want to use n. So we want to use a sub n. So to figure out my rule, to get to any generic term, you start with the first term, you add your common difference, n minus 1 times. Okay, I'm not going to plug in 23 for a sub n. I'm trying to write a rule here. I want it to be generic. So I'm going to leave the n's where they are, but I'm going to plug in my common difference. I'm adding 3 every time, and my starting number of 2. Okay, and the goal here is just to pretty this up a little bit. Distribute there, I'm going to get 3n minus 3. So my rule is going to end up being 3n, and the 2 and the minus 3. That's going to be a minus 1. All right. Okay, so that's my rule. So then when I go to write my actual summation notation, right, we're going to draw this lovely little symbol. I know it's kind of a weird thing to draw at first, but it's not too bad. Just make this little straight up piece here, and then you just kind of zoop, 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 and there you go. Okay, so for this particular one, I started from the first term, and then we did 1, 2, 3, 4, 5, 6, 7, 8 terms. So I added the first 8 terms. So again, that just tells you where to stop. And my rule is 3n minus 1. Okay, so this tells me add together from the first to the 8th term of the series described by this rule. Okay, and if you check any given number, like this is, let's see, this is the 3rd term. You plug 3 in here, 3 times 3 is 9, 9 minus 1 is 8. Okay, so that's all that rule gives you. All right, so here's a rule that's already been set up. You'll see sometimes these are written in parentheses, sometimes they're not. It's not a huge deal. It just sort of depends on how well you need to group the thing together. Okay, so let's look at kind of going the opposite direction with this one. So this guy, we want to find the actual sum. Okay, so this one, we're going to, I guess, find this. So what this means is we're going to find the sum from the 1st to the 12th term. Okay, so it's the sum of the first 12 terms described by this rule. Okay, now I could work this out and just figure them all out, right? What all the different terms are, but I want to kind of use the formula that we've been using this rule, right? Find the first number, the last number, add them together, and divide by how many there are. So I'm going to start by finding a sub 1. And to do that, all you have to do is just plug 1 into this rule. So 4 times 1 is 4. 4 minus 3 is 1. Okay? And again, what I did there, let me go back and do this. So I did 4 times 1 minus 3. And that 1 is because this is an a sub 1. Okay, then I need to know what my last term is, the 12th term. So to find a sub 12, I'm going to do 4 times 12 minus 3. I'm plugging 12 into this rule. 4 times 12 is 48. 48 minus 3 is 45. And that one we said equaled 1. So I got my first term and my last term. Now I can go back and use that rule to find the sum of the first 12 terms, add together the first term and the last term, and then multiply by how many pairs I have. If I have 12 terms, we know there's going to be 6 pairs, right? It comes from 12 divided by 2. Throw that in your calculator, and the sum of the first 12 terms is 276. Okay, so that's the answer that we're looking for. You could also, like in terms of formatting of how this would look like, you could also write it in terms of, sorry, you need the sound effects to draw them properly. So you could write it like this and say that equals 276. That's the same thing. Okay, so it's just a different notation. Instead of writing the sum of 12 or s sub 12, you'd write it that way. All right, and that is how you find the sum of arithmetic sequences. It's not super hard. You just got to kind of engage your brain, and you really got to kind of think about the logic of this. If you can get that logic to click, it makes it a lot easier to figure out all these different pieces.